Math 1314, section IC1, spring 2022, Tyler Junior College, homework 9.1/9.2, inverse functions, exponential functions, video 6, interest problems. Notice I didn't say interesting problems, but that might depend on how much you like money. All right, so what do I mean by interest? Well, when I mean interest, I mean when you borrow or loan money and somebody pays you or you pay somebody extra for the privilege of borrowing that money and paying it back in the future. Interest is just the fee charged for the privilege of borrowing money now and paying it back later. And there are three types of interest we're going to look at. You may be familiar with these. The first is called simple interest. Simple interest is when interest is added at the end of a loan or investment. So you borrow money, we part ways, and when we come back and say, all right, let's calculate how much interest you owe, pay me back what you borrowed plus the interest. The formula for simple interest is really simple. The formula for simple interest is right here. I equals PRT. I is the interest earned, P is the principal, which is the amount borrowed or invested, R is the interest rate, which is given as a percent but used as a decimal. So make sure you know how to convert percents to decimals. I'll remind you here in these upcoming examples. And T is the time in years. Now, you can do investments and loans for months or days or weeks or whatever. You would just have to multiply or divide to scale your unit of time from whatever it is to years. For example, if you said, I'm going to invest this for 30 months, then you would divide that by 12 and figure out that that's 2.5 years or 2.5 years. All right, let's take a look at a simple interest example. Suppose you invest $5,000 at simple interest at a simple interest rate of 3.2% for 6 years. A, how much interest is earned? And B, what is the future value of your investment? Well, let's tackle the interest earned first, because this is going to be the easiest part. Second part's, actually, I would say the second part's easier. But first, let's identify the values that we were given. Since we're investing $5,000, our principal, capital P, is $5,000. Our interest rate is 3.2%, but you don't do percent with math with percents. You do math with decimals. Percents are good for describing things, bad for doing math with. So how do you turn a percent into a decimal? The answer is you move the decimal 2 places to the left. Put that in red, please. That's what I thought it was. Now, there's only 1 digit to the left of this decimal. And if you need to move the decimal place 2 places over, then you just have to put an extra 0 in. So again, if I'm going to move this decimal 2 places to the left, I'm going to have to introduce an extra 0 in front. And so as a decimal, 3.2% is 0.032. Now, it's not necessary to put the 0 on the left of the decimal. That's just a personal preference of mine. And our time is 6 years, so T is equal to 6. So part A is pretty easy. Our interest is principal times rate times time. Our principal is 5,000 times our interest rate, which was 0.032, times the time, which is 6. And I'm just using adjacency to imply multiplication. In other words, writing the numbers next to each other in parentheses means I'm going to multiply them. 5,000 times 0.032 times 6, and we end up with 960. Now, this is a dollar amount, so we'll stick dollars on it. So in 6 years, we'll have made an extra $960. Now, we didn't talk about what future value is yet, so let's have that short discussion right now. Future value is just your principal plus your interest. In other words, how much do you have in the future? Hence the name future value. Well, our principal was $5,000. And we made an extra $960. So our value in the future is $5,960. The concept of future value is actually pretty easy. It's just what is the value that you have in the future. And if you're wondering why I'm erasing all this, because it's going to be a lot cleaner, and I wish I'd done this first, if I had typed I equals PRT, which is equal to $5,000 times 0.032 times 6, and that ended up being $960. Yeah, I just added an extra 8,000. I wish it were that easy. All right, so it's actually pretty simple to use the simple interest formula. Now, the second type of interest we're going to talk about is called compound interest. Now, don't be intimidated by the words or the number of letters and stuff. In fact, let's just cover that up so that you're not all panicky yet. Okay, there it is. All right. Interest is calculated at regular intervals during the investment and added to the principal. Hence, your interest starts earning interest. So in other words, let's say you got a pile of money, and then the bank says, all right, come back at the end and then we'll calculate the interest. Well, compound interest says, well, before you come back, after a certain amount of time, like after a month, we're going to shut it down, calculate the interest, add it in, and then resume. So my pile of money just got bigger. And each time interest is added, my pile of money gets bigger and bigger. So not only does my original principal start earning interest, my interest starts earning interest. Banks do this to be competitive with each other because you actually get more money in the long term than just rather letting your money sit. And then you wait at the end to calculate interest. All right, now the formula for compound interest is a little bit more busy. It's A equals P times 1 plus R over N all to the NT power. Now, normally I would write this because I prefer my fractions vertical. So when I write it, it's going to look like this. P times a tall set of parentheses, 1 plus R over N, close the tall parentheses, but in the exponent, N times T. Now, what are all these pieces? Well, the P, the R, and the T are the same things that they were before. But what's the A and what's the N? Well, the A is the future value of your investment or loan. So it's important to point out, and it says it at the bottom, that this formula calculates future value, not interest. P is still the principal, R is still the interest rate, T is still the time. But what the N represents is the number of times per year interest is compounded. So for example, if I said, I'm going to give you interest semi-annually, semi-annually means 2 times per year. So N would equal 2. Or if I said, I'm going to pay you interest quarterly, a quarter of a year is 1/4 of a year, so about 3 months. So quarterly would mean I get interest 4 times per year. N would equal 4. Usually the N is not given to you as a number, but as an adverb, like weekly, monthly, quarterly, semi-annually, or annually, in which case N equals 1. Let's take a look at an example. Suppose you borrow $2,500 at a compound interest rate of 6.25% compounded monthly. How much will you owe in 2 years? How much interest accumulated? It sounds funny, but we'll leave it like that. All right, let's identify all the pieces that we're given. The first piece that we're given is the principal. We're borrowing $2,500, so we're flipping it. We're doing a borrowing money problem. Our interest rate is 6.25%, but let's go ahead and turn it to a decimal, 0.0625. And because it says compounded monthly, how many times a year is something if it happens monthly? The answer is 12, which means N is equal to 12. And then in the statement of the question, it says, how much will you owe in 2 years? That's what T equals. So for part A, our future value, which is called A, that's the best choice of letter for future value. Let's call it A. I wasn't there for that decision. Our future value is the principal. I'm recopying the formula, times 1 plus the interest rate over N, and in the exponent, N times T. Our principal is 2,500. In the parentheses, we have 1 plus the interest rate, which is 0.0625, divided by the N, which is 12, close parentheses, and in the exponent, we have N times T, which is 12 times 2. Now, the issue with this usually isn't the setup, it's the execution in your calculator because there's so much going on. My advice for you for typing this in the calculator is twofold. Number one, go ahead and figure out what this multiplication problem equals and replace it. 12 times 2, well, that's easy. 12 times 2 is just 24. But that's the only thing you should calculate in advance. Everything else you should type in as is. The reason why is that if you try to do this and write it down, most of the time that decimal goes forever. And when you write down, you stop writing and you've rounded off your answer, which can create an incorrect answer at the end. So simplify the power because it's just a multiplication problem, but then type the rest of it in your calculator. Now, as a typing in a calculator, it would go something like this. 2,500 times, open parentheses, 1 plus 0.0625, let me widen this, divided by, and I'm going to type slash for divided by, 12, close parentheses, press your exponent button, whatever it looks like, raise it to the 24th power, and press equals. I highly recommend trying to do this right now because, again, the biggest issue for some people in this is not the setup, but the execution inside of your calculator. This is a dollar amount, so it makes sense to round it to the nearest cent. To the nearest cent, you should get $2,831.95. That's assuming I typed it correctly. I'm going to do it again because it doesn't matter how good you are. It's easy to make a mistake here, especially if you're typing while you're talking. But I got the same answer again. All right, so that represents our future value. So in other words, we borrowed $2,500, but now I'm going to have to repay $2,831.95. And to be honest with you, that's not a lot to repay if I'm going to pay it back after 2 years. But how much interest did we have to pay? Well, remember when we calculated the future value back here by adding the principal plus the interest? Well, now we want to know the interest, but we know the future value and the principal. So what can we do to figure out how much extra we made? Well, that's actually pretty easy. And we'll just type this and we'll type it in red. Our future value is just going to be, excuse me, we have our future value. We want to know the interest. Our interest is just going to be our future value, how much we owe in the future minus how much we borrowed. Principal. Interest is the future value minus the principal. How much extra do we owe? Well, in the future, we owed $2,831.95, but we only borrowed $2,500. And if we subtract those, it looks like we get $331.95. So again, this formula calculates future value, not interest. If you want to know interest, take your future value, subtract the principal. If you borrowed, it's how much extra you have to pay. If you invested, it's how much extra money you make. All right, we're going to take a look at one more type of interest problem. And just like before, don't panic just because this looks like this. It doesn't mean that it's difficult. It just means that it's a different formula. We'll cover that up for a second. 1 second, folks. All right, the last type of interest that we're going to look at is called continuously compounded interest. And the genesis of this idea is if we go back to this type of problem where interest was compounded monthly, I'm not going to prove this, excuse me, but you can accept it at face value that the more frequently interest is added, the more interest you have at the end. It's because your pile starts getting more money sooner, and that money gets an opportunity to grow longer. So the more frequently interest is compounded, the more interest you have at the end. Now, there's a cap to how high it can get, and that's why it's called continuously compounded interest. Interest is theoretically calculated and added to your principal nonstop. You do monthly, I do weekly. You do weekly, I do daily. You add interest daily, I'll add interest hourly. You add interest once an hour, I'll do once a minute. I'll do once a second. I'll do twice a second. I'll add interest 10 times a second. I'll add interest 100 times a second. I'll add interest 1,000,000 times per second. Now, in practice, you can't pause and do something 1,000,000 times in 1 second, but you can calculate what would happen and then make it happen. You can think of it like a running faucet adding water to a sink. And as the sink grows, you turn on the faucet so the water starts coming out faster. The water's representing the interest that's added on to your principal. All right, so how does it go? Well, the formula brings in the natural base E. I told you this was going to show up in the previous video. The formula is A equals P times E to the RT power. A is the future value, P is the principal, R is the interest rate, T is the time in years. Now, it's not a coincidence that the E shows up here, because the compound interest formula, if you were to look at it really closely, contains a version of the thing that creates the E. Just a reminder from the video about the natural base E, E is the horizontal asymptote, E is the horizontal asymptote of the function f of x equals 1 plus 1 over x to the x power. And if you'll notice, there are some components of this function that resemble our formula that resemble this function. The 1 plus in front, the fraction with something on the bottom, and that something showing up as an exponent. The R and the T are just, they're just, tagging along, if you will. They're riding the coattails of everything else. But because the structure of the compound interest formula is structurally similar to the function that creates the horizontal asymptote at y equals E, it's not a coincidence that when well, let's think about it. Let's put all that back for a second. Horizontal asymptote dictates in behavior, which is what happens when x gets really large. But in our formula here, it's not x, it's n. When n gets really large, that means we get interest more and more frequently. And as n gets closer to infinity, that means that we get interest continuously, hence the phrase continuously compounded interest. Now, if that made sense, great. And if it didn't make sense, that's okay, because here's what you need to know. You need to know that when you see the word continuously in a problem, this is the formula that you use. That's all you really need to know. You see the word continuously in an interest problem, you will use A equals P times E to the RT power. Now, before we do the last example and wrap this one up, I want to remind you that like compound interest, this formula only calculates future value, not the interest. So let's take a look at an example. Calculate the future value and interest earned on an investment of $1 million compounded continuously at 4.325% interest for 1 year. Now, I know most people don't have a spare million to float around, but let me tell you a little something. I don't know when you plan on retiring, but you should start investing in it right now. Because when you get to the end of your career and you choose to retire, what the ideal situation is to have such a fat lump of money like $1 million to sit in the bank, and you live off the interest for the rest of your life. So is 1 million enough to do this if this is the interest rate that we can procure for us and see what we get in a single year? All right, let's do the math. First off, our principal is $1 million. There's the word continuously, which means we're going to use the A equals P times E to the RT formula. Our interest rate as a decimal is 0.04325. Make sure you move that decimal exactly 2 places to the right. One decimal place too many or too few can give you a really low value or a ridiculously high value for your answer. 1 second, folks. All right, sorry, folks. I had another phone call I had to take real quick. We got the principal, we got the interest rate, we're doing compounded continuously, and we're doing this for 1 year. So T is equal to 1. Let's set up our formula to find the future value first. Our future value is P times E to the RT power. Our P is 1 million. Some commas for clarity. E is a constant, it's a number, don't replace it with anything. R is 0.0435, and we're going to multiply that times T, which is just 1. I'm going to make the same recommendation here that I made for compound interest, the part highlighted in yellow, the multiplication problem and the exponent. I would go ahead and calculate that first because it's easy. You'll never have to round anything off. And in this case, it's really easy because it's times 1. But I would just put that in a calculator and figure out that answer first, 0.0435. And now in your calculator, you would type something like this. We'll put it in blue. You would type 1 million times, bring up your E, however you do it, raise E to the 0.0435 power and press equals. And let's see what we get. Please try this in your calculator because these are keystrokes that may be new to you. 1 million times E to the 0.0435, and I get 1,044,000. So there's a zero in there, $459.99. That is a dollar amount, so we'll throw a dollar in front of it. And, we'll throw the dollar in front of the million also, and maybe some commas, just because. All right, so if you got that answered, that's great. But what interest is earned? Well, the interest is how much we have in the future, $1,044,459.99, minus the $1 million that we started with, equals $44,459.99. So in this fictitious scenario, if you have $1 million and you can get a 4.325%, oh, I just realized that my interest rate was written incorrectly. That was right when I got a phone call from my daughter who's in college. Oops. And I knew that she needed something now. And so let's see, 325. So underneath here was 325. I'm just going to fix all this real quick. In fact, let me pause it and fix it. All right, you see how easy it is to make the most careless of mistakes. Now, I credit it to the fact that as I was writing down the interest rate and my phone was ringing, I was distracted. Luckily, we caught it here in the homework. Of course, it would tell you the answer is wrong. You'd have to go back and figure out what you did wrong. But it shows you that it doesn't matter how good you are or how good you think you are. If you're not careful, you can make the most subtle of mistakes, which might have catastrophic consequences in real life. Now, I haven't recalculated the interest yet. I did fix everything up until here. I just haven't recalculated the future value yet, but I did correct all the R's elsewhere written above. So let's pick it up from here. We'll wrap this up, and that'll be into this video and the series of videos for this particular homework. All right, all I have to do is go back and retype what I typed before in my calculator and change the decimal to 0.04325. And let's see if it makes a huge difference. Well, it did, because when I put the 2 back in there, it actually lowered the interest rate a little bit. And so it dropped it from $1,044,459.99 to $1,044,198.91. So it looks like it went down maybe about 250 some odd, maybe $260 over the course of a year. So that's not, life-affecting money over the course of 1 year. Oh, an extra 260, or at least I don't think it is. But then again, maybe that's just my opinion. But let's fix all this, because the question I wanted to ask you is, if this was your retirement plan, interest is $44,198.91. If this was your retirement plan, could you live on $44,198.91 per year? Now, if you're quickly going to say yes, then chances are you might still be a full-time college student and not have things like mortgages, car payments, medical bills to pay off. Maybe you do, maybe you don't. But I mean, that could be that you could live on that. But could you live comfortably on it? Could you travel the world? Could you take cruises? Could you go to New York, go to Broadway and watch shows, 2 or 3 or 4 or 5 times a year? The answer is probably not. So it's something you could live on, but it's something you couldn't live extravagantly on. And this kind of shows the dilemma in trying to retire. If I want to have a chunk of money to live on, can I just live on the interest? Because if this were large enough, let's just say for a moment that this is large enough for you to live on comfortably for the rest of your life, then you're set. Because each year you would live on the interest, the 1 million would go untouched, and the next year it would generate another $44,198.91. How do you get more money when you retire? Well, either you get more principal or you get a better interest rate. And guess which one you have more control over? The principal.